All right. My name is Curtis Covington, and here's a presentation on an analysis of basketball shot mechanics. I'm doing this for my AI class project. So, project overview. The primary goal of this project is to see if we can use biomechanics to predict basketball made or missed shots. And the eventual hope is to be able to take videos of players shooting and give them instant feedback on why they're missing shots they are missing and how they can adjust their form to make more shots. So I took 100 three-point shots and recorded them in slow motion with both a front and a side-facing camera. And then I took all that data and used MediaPipe pose estimation to track 32 points on the body throughout all of the video. And then that spit out a bunch of coordinates from different points on the body. And I created features using those coordinates based on different mechanics of shooting. And then I trained a model to predict makes and misses based on those features. So the first step in this project was to figure out how to detect shots. And I had to do this slightly differently for the two different camera angles. So on the left, this is for the front-facing camera. I used knee and ankle peaks when I jumped, and the peaks would line up at the same time. And if I have two peaks around the range that I specified at the same time, I would say there's a shot there. And then on the right, I actually just used X and Y coordinates for the wrist from the side angle camera. And when those lined up, I was able to detect a shot. And these actually gave me probably about 95% accuracy on detecting shots. I had to come through and clean up some of the mistakes there, but overall pretty good accuracy for being able to detect shots. And from there, I set a specific amount of frames before the different peaks and after the peaks to slice up and put in a data frame to be the data for one shot. So then I ended up with 100 different slices of data for each shot. So feature generation, I started with biomechanic analyzation. So this includes stuff like stance width, dip depth, knee flexion angle, elbow flare, release angle. And while these were interesting, they ended up not being the most correlated to whether or not I made or missed shots. So I generated a bunch of features, over 100 different features based on coordinates from my data set. And I used the top 15 correlated values, and I should display the top 5 on the right here. It's interesting looking at these. The first one really actually just shows how close my left foot is to the hoop. So there's sometimes I started further back from the three-point line, and sometimes I started a little closely, and that was actually the most correlated feature with whether or not I made or missed. And we can go through some other of these. So one is how much my knee dropped, which displays depth, hip drop, or knee flexion. And then there's a couple others that are kind of interesting there as well. So I have a couple videos. This is how the pose estimation did on my shot tracking from both angles. And you can see it actually did relatively well. There are some spots where it's a little shaky, but overall I was happy with how the pose estimation turned out. And you can see on the elbow it swings around a little as I'm bringing the ball forward. But overall pretty good pose tracking. So for the model training, we didn't end up using any of the biomechanic features, but for the training I did, basically I split the data in the training set into 5 sections, and I would train 4 sections and test on the 5th section, and that's that first number there. And linear SVs, or logistic regression model, got up to almost 70% accuracy there. And then I used all 5 of those training pieces to look at the test set, and not super high accuracy there. So some other interesting results. So I took 100 shots, and my shot slightly changed over those 100 shots. So you can see the dip depth, how much I'm bending my knees and trying to use my legs, decreases a little bit over time. You can see some fatigue. And this on the top right is the set point height. So it's how high my elbow is when I'm like set my shot to shoot. It actually increases over time, maybe a little bit to compensate for the dip depth. And then we have some other correlations on the bottom. And then I also applied my release angle over time, and that's elbow relative to the torso. And that got a little flatter over time, showing I probably didn't have as much power, so I had to make my shot just a little flatter to make it still get to the hoop. So in conclusion, I learned is post tracking alone does not provide enough insight to predict makes or misses, at least on this training set. I ran some models with just the biomechanical calculations, the things that you would think would predict shot making the most, and the best my models got was about 50%, which basically is doing nothing there. But there are some other valuable insights which can help players adjust their form to better known techniques. They can help analyze if there's something wrong with your form, and then you can go back and try to tweak it after. Techniques as or different things that I've talked about, such as how much you bend your knees, where you place your feet, if your legs drift when you shoot, stuff like that. So overall, still interesting insights you can find with post tracking on basketball shooting. And lastly, I'd like to give special acknowledgement to my wife. She was my rebounder for this project and recorded all the makes and misses for me, which was exactly 50 out of 100, which was fun because it was perfectly balanced data set. So yeah, that's it. Thank you so much.